Now let's delve into the preparation for the CompTIA SecurityX Certification course, focusing on governance, risk, and compliance. Specifically, we will look at how to perform threat modeling activities using various frameworks. Firstly, we have the MITRE Adversarial Tactics, Techniques, and Common Knowledge, a comprehensive catalog used to identify and mitigate security risks. Next, the Common Attack Pattern Enumeration and Classification framework is designed to understand and mitigate software vulnerabilities. The Cyber Kill Chain model outlines the stages of a cyber attack, from reconnaissance to actions on objectives, helping to identify and disrupt each phase. The Diamond model of intrusion analysis offers a structured approach to analyze cyber threats and intrusions. STRIDE is a mnemonic for the 6 threat categories: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Finally, the Open Web Application Security Project, OWASP, provides resources to improve the security of software through community-driven open source projects. Understanding these frameworks is crucial in performing effective threat modeling, allowing us to anticipate potential attacks and strengthen our defenses accordingly. The MITRE Adversarial Tactics, Techniques, and Common Knowledge attack framework is an essential tool in cybersecurity. Its primary purpose is to provide a detailed catalog of adversary tactics and techniques, helping organizations identify and mitigate potential security risks. For example, attack outlines various tactics like initial access, execution, and persistence. These tactics include specific techniques such as spear phishing, using PowerShell, and creating scheduled tasks. To utilize the attack framework efficiently, consider the commands. For instance, to query the ACK database for specific tactics, techniques, and procedures (TTPs) related to spear phishing, you would use HTTL query TP spear phishing. And to generate a list of mitigation strategies tailored to certain techniques, you might use HTTL generate mitigations techniques T71 T86. By leveraging these tools and techniques, you can proactively address security vulnerabilities and improve your organization's defensive posture. Continuing our discussion on cybersecurity frameworks, let's now focus on the Common Attack Pattern Enumeration and Classification, or CAPEC. The purpose of CAPEC is to provide a standardized classification of known attack patterns. This makes it easier for organizations to understand and anticipate common attack strategies. For example, CAPEC covers categories such as abusive and fraudulent activity, as well as data leakage attacks. These categories help in identifying the broader context of each attack pattern. Using tools designed to interface with CAPEC, you can execute commands like capecl fetch data to retrieve the latest CAPEC data for analysis. Another useful command is capecl list category data leakage attacks pattern SQL injection, which lists attack patterns specifically related to SQL injection within the data leakage attacks category. These functionalities assist in maintaining an updated understanding of potential vulnerabilities and preparing appropriate mitigation strategies. The Cyber Kill Chain is an essential framework used to describe the stages of a cyber attack. It outlines 7 distinct phases that adversaries typically follow to accomplish their objectives. These stages are reconnaissance, weaponization, delivery, exploitation, installation, command and control, and actions on objectives. By understanding these phases, organizations can track and interrupt adversarial activities effectively. This framework aids in the identification of attack patterns and the implementation of defensive measures at each stage, enhancing the overall cybersecurity posture. The Diamond model of intrusion analysis is a framework designed to illustrate the relationships and patterns inherent to cyber intrusions. This model is particularly useful for analysts as it helps identify and visualize the interactions between key components of a cyber attack. The core vertices of the Diamond model are adversary, infrastructure, capability, and victim. Adversary represents the threat actor or group initiating the attack. Infrastructure refers to the physical and virtual resources used by the adversary to launch and sustain attacks. Capability encompasses the tools, techniques, and procedures employed by the adversary. Victim denotes the targeted individual, organization, or system. By analyzing and mapping these elements, security teams can prioritize and respond more effectively to threats. The Diamond model facilitates a deeper understanding of the adversary's operations and intentions, helping organizations to predict potential future actions and mitigate ongoing threats. Now, let's delve into the STRIDE methodology. STRIDE is an acronym representing 6 categories of threats that can be used to identify and evaluate potential security issues in software development. Firstly, spoofing refers to the act of pretending to be another user or system. This can lead to unauthorized access and data breaches. Tampering involves altering data or code illegally, undermining the integrity of the information. Repudiation is the ability of users to deny having performed an action without other parties being able to prove otherwise. Information disclosure exposes sensitive information to unauthorized users, which could lead to privacy violations and data theft. Denial of service attacks disrupt the availability of services, making systems or networks unavailable to end users. Finally, elevation of privilege occurs when a user gains higher access levels than permitted, potentially compromising the entire system. By categorizing threats using the STRIDE model, software development teams can systematically identify and address security vulnerabilities, enhancing the overall security posture of their applications. The Open Web Application Security Project, or OWASP, is an initiative with the primary goal of enhancing software security through community-driven open-source projects. One of the most recognized outputs from OWASP is their top 10 list, which identifies the most critical security risks to web applications. Some of these risks include injection flaws, broken authentication, and sensitive data exposure, among others. OWASP's projects provide valuable tools and guidelines that developers and security professionals can utilize to analyze and improve the security posture of their applications. For instance, OWASP ZAP, a popular tool, can be used to scan web applications for vulnerabilities. Using the command zapcli start initiates the tool, and zapcli quick scan http://example.com performs a swift security scan of the specified web application. Another useful OWASP tool is the Header Security Project, which can analyze security headers of a web application. A simple command like curl example.com grep xkind content options can help identify headhunt security by preventing MIME type sniffing, for example. Incorporating OWASP tools and adhering to its guidelines, you can significantly enhance the security defenses of your software and ensure adherence to best practices in application security. This approach not only identifies current vulnerabilities, but also helps in building more secure software from the ground up. In this section, we'll dive into real-world scenarios and best practices, focusing on identifying and exploiting SMB vulnerabilities. Let's start with a practical scenario. Suppose you need to identify SMB vulnerabilities within your network. One effective technique is to use Nmap. By executing the command nmap-p445-script smb-ful 192.168.1.024, you can scan your network for SMB-specific vulnerabilities on port 445. This script-based approach helps in detecting various SMB vulnerabilities efficiently. Next, it's crucial to verify the SMB signing status, which can prevent man-in-the-middle attacks. The command crackmapeexec smb192.168.1.10-u administrator-p password1-shares can be used for this purpose. It allows you to check the SMB signing status and enumerate shares on a specific SMB host. A best practice in this context is to ensure that SMB signing is enforced and proper firewall rules are in place to restrict unauthorized access. This reduces the attack surface and enhances the overall security posture. By following these steps and adhering to recommended best practices, you can effectively identify and mitigate SMB vulnerabilities in your network. In this slide, we'll summarize the key points we've covered so far. It's crucial to understand the different threat modeling frameworks and methodologies. These provide the foundation for identifying, assessing, and mitigating vulnerabilities in your network. Familiarity with various tools and commands is also essential to effectively implement these models. Tools like Nmap and crackmapeexec have been highlighted to detect and assess vulnerabilities, particularly in SMB services. By applying real-world scenarios, you can put theoretical knowledge into practice. For instance, using Nmap to scan for SMB vulnerabilities and ensuring that security implementations such as SMB signing and proper firewall rules are in place. These practices help create a more robust and secure network environment. Remember, the goal is to not just understand these concepts, but also to implement them in practical scenarios for better threat detection and mitigation. In this slide, we provide essential references to aid your understanding and application of threat modeling methodologies. The MITRE ATT&CK framework is a comprehensive knowledge base of adversary tactics and techniques, which is crucial for mapping out potential threats. CAPEC, or the Common Attack Pattern Enumeration and Classification, offers a detailed taxonomy of common attack patterns which can help in identifying and categorizing threats. The Cyber Kill Chain provides a structured approach detailing the stages of a cyber attack and enabling the identification of defensive measures at each phase. The Diamond model enhances this by focusing on the relationship between adversaries and their capabilities, infrastructure, and victims, offering a broader perspective on threat analysis. Finally, OWASP, the Open Web Application Security Project, is instrumental in providing resources and tools specifically tailored for securing web applications. These references collectively form a strong foundation for effective threat modeling, allowing you to better evaluate and enhance your security posture. Thank you for your time and attention throughout this course. Your engagement is important to us, and we'd love to hear your thoughts. If you enjoyed the content, please leave a like. Your feedback helps us improve and create better content in the future, so feel free to comment below. To stay updated with the latest in cybersecurity and other technical courses, subscribe to the channel. And remember, sharing this content with your friends and colleagues can help spread valuable knowledge across your network. Thanks again, and we look forward to your continued learning journey.